Hello, and welcome back to our video lecture series for our course MGMT205, Management Information Systems. This week we're going to be covering Chapter 7, Processes, Organizations, and Information Systems. We're beginning Module 3 with Chapter 7, and in this module we're going to be looking at different types of information systems and the levels within the organizations that these various types of information systems serve. In this opening chapter, we're going to be specifically looking at enterprise-wide systems and, of course, the processes within the business that these systems enable or improve. So, in today's lecture, we're going to be covering, of course, business processes, what they are, how they are structured, and how to document them. And of course, in understanding business processes, we'll understand how information systems can help to improve the quality of how business processes take place. Next, we're going to have a very brief conversation about information silos. What are these, and why are they bad? And how can information systems help eliminate both the information silo and, of course, the effects of an information silo. To do this, of course, we're going to be looking at enterprise-wide systems, or what we call ERPs. And we'll wrap the chapter up by looking at how an ERP is structured and designed. So let's begin. Right, so what are the basic types of processes? And of course, we're talking about business processes. A business process is a network of activities that generate value by transforming inputs into outputs. Activities, of course, are the subparts of a process, like the various steps in a process that receive inputs and produce outputs. Now, in a business, everything that takes place, from performing recruitment to ordering stock, to moving stock from a warehouse into the manufacturing, to receiving a call by a customer to complain about a product, to aftercare service, doesn't matter. Everything that happens in a business is a process. And these processes are designed by management to fulfill the goals of the company and to fulfill the needs of their customers. Every process is made up of a series of activities or steps. What are these steps? How are they comprised of? All that will be determined by what the process is aimed at achieving. We're not going to be designing any processes at this point in time, but at least you need to understand that processes are the building blocks, the very foundation of everything that happens in a business. And in understanding these, we will now be able to understand better how information systems can be implemented into the organization and how they can serve to improve how things happen within the organization. Nonetheless, back to processes and their activities. Activities themselves can be performed by human beings, or they can be performed by human beings assisted or augmented by computer-based systems, or activities can be performed entirely and exclusively by computer-based systems without any human intervention. If we go back to our Chapter 1 discussion and we remember our 5-component model of information systems, remember that there was the technology side and the human side. And in that illustration of the 5-component model, we saw that how at the extremes we had computers and we had humans or persons, people. And we had said that how these entities, computers and people, are the actors. This is what we were referring to. The computers and the humans are the ones who can perform or act out the activities in an organization in its various processes. Now, businesses have dozens, hundreds, or in some cases even thousands of different processes. Some processes are stable, almost fixed sequences of activities and data flows. These are what we call structured processes. Structured processes are formally defined. They are standardized processes that involve day-to-day operations, things that happen again and again and again. Examples of structured processes include accepting a returned product from a customer, placing a new order for stationery stock, or even purchasing raw materials. These are things that have happened before, have happened many times before, and will continue to happen going into the future. As such, the process for performing each of these activities, each of these functions, are structured. There are rules and procedures that have been defined as to how this is to happen, or how these activities are to take place, and in the order and when they are to take place. Now, while you do have some processes that are structured, other processes are less structured, less rigid, and often creative. In other words, we're talking about processes that do not happen frequently, processes that may be one-off or very rare when they happen. So we call these dynamic processes. Dynamic processes are flexible, informal or somewhat informal as the case might be, and adaptive processes that normally involve strategic and less structured managerial decisions and activities. And these can include, for example, deciding whether to open a new store location, because it's not every day you're going to do that. And even if you have opened a store location before and you have 10 store locations, every store location is different with different situations and different scenarios and different communities with different levels of interest in your product lines. So there's a whole lot of considerations that are unique. So any process that is involved in setting up a new location is going to be a relatively new process. Even if some aspects are familiar, there will always be new aspects because, well, it's a different situation. Another example will include deciding how best to solve the problem of excessive product returns. Now, we've already identified that accepting a product return from a customer is a routine function. That's structured. That's true. However, if you find that there are too many people returning products and it is an unusual development, typically you may have 3 or 4 returns per month in the past, but right now you're experiencing 14 or 15 per week. Something may be wrong. And figuring out the cause of this problem and figuring out how to solve this problem of excessive product returns is basically defining a process that is a relatively new and dynamic process. All right, so let's make a comparison between structured and dynamic processes. I'm not going to go through all of this because it's documented here, and of course it's in your textbook. But of course, structured processes support operational and structured managerial decisions and activities. They are standardized. They are usually formally defined and documented. Exceptions to these processes or how the processes are, processed are rare. And very often they are not well tolerated. On the other hand, dynamic processes tend to support strategic and less structured managerial decisions and activities. They are less specific and very often they are fluid. In other words, they exist to resolve things that are constantly changing. They are usually informal, and because they're informal and because they represent fluid situations that are changing and evolving, you tend to find that exceptions to any established rules are frequent, and in fact you expect to have exceptions. All right, well, you can go through this and the examples that are given here. Now, we have different levels of processes that take place within the organization. We're going to start off, of course, with at the lower levels, and then we're going to get all the way to the um, organizational wide functions or processes. So, work group processes. A work group process exists to enable work groups to fulfill the charter, purpose, and goals of a particular group or department. So, in other words, we can almost rename or give a subordinate name to work group processes as departmental processes or team processes or group processes, but they're just called work group processes for now. Typically, work group processes may receive inputs from other departments and they may produce outputs that are used by other departments. But the bulk of the process's activities lay within a single department. So it is intrinsically a departmental process, even though it may depend on a report that comes from another department. And at the end of your process, it may provide details or reports to some other department elsewhere. So those are the inputs and outputs we're talking about. A workgroup information system exists to support one or more processes within the workgroup. For example, an accounting department might implement 2 or 3 different information systems solutions to support its various accounting, cash flow management, and financial processes. Workgroup information systems are also called functional information systems, since these information systems support functional activities in the organization, such as, well, we covered accounting already, but we have marketing, manufacturing, HR, R&D, and you name it. So the next 2 slides, we're going to look at some examples of workgroup processes and, of course, the work groups that they are part of. We've already mentioned accounting. So here are some of the other processes that take place in accounting. So we have general ledger, financial reporting, cost accounting, accounts receivable, accounts payable, cash management, budgeting, and treasury management. All of these are different processes, each with its own sub-processes that are part of the accounting function. And then, of course, we have the operations department, or it might be customer service, or it might, whichever would be considered operations depending on the kind of business that you're running. And here we have order entry, order management, finished goods, inventory management, and so on. And there'll be others. These are just examples. Manufacturing will include, of course, inventory, which of course would include raw materials in stock as well as goods in process that you've already started the manufacturing on but have not finished its manufacturing process. We have, of course, planning, scheduling, and operations. Sales and marketing. So we have different processes here that include lead generation, lead tracking, customer management, sales forecasting, product and brand management. Now, for those of you who may not have done marketing, or depending on who your lecturer was, may not have understood the concept of a lead. A lead is basically something that helps you identify a prospective customer. So that lead might be, let's say, for instance, a reference or recommendation. In the case of an insurance sales officer, a sales agent, an insurance agent, if that insurance agent has a customer, he typically asks that customer, hey, do you know anybody else who wants an insurance policy? Do you know anybody else who might be in need of an insurance plan? And that person may give them the names of 3 or 4 persons. Those names are leads. And of course, now that you've generated those leads, you now have to get in contact with those persons, and you now need to do your pitch to try to convert them from being a prospective customer into becoming an actual customer. So that's just a little bit of marketing. right? There's a process involved in all of these things. We have customer service and we have human resources, right? You can go through these. Now, beyond the work group level or departmental level processes, we have enterprise-wide processes. So, enterprise processes span an entire organization and support activities in multiple departments. For example, at a hospital, the process for discharging a patient supports activities in housekeeping, the pharmacy, the kitchen, nurses' stations, and other hospital departments. So, understand this. Enterprise-wide processes are not just confined or limited to a single department with minor inputs and outputs to other departments. No, these are intrinsic and core processes that affect the whole organization or affect multiple departments in major ways. The discharge of a patient impacts on housekeeping because you have to go and ready that bed for another patient, ready that room for another patient, do whatever sanitization routines and whatnot that you have to engage in. It involves the pharmacy because many patients would have to be provided with medications and so on, as well as guidance on how to use those medications in home care, and so on and so forth. So there's a lot that goes on in simply discharging a patient. There's a lot that goes on in CUSTAT when we accept a student to join the institution. And it affects many departments, from student services, admissions, registry, your chosen academic department, developmental advising, and so on and so forth. So those are enterprise-wide processes. Registration, just to get registered, is a very wide or broadly embraced enterprise process in CUSTAT. Enterprise Information Systems, or EIS, support one or more enterprise process or many processes, and they typically have hundreds to thousands of potential users of this system. Now, in the case of CUSTAT, which we have below, we do have Banner, and Banner is used by thousands of people simultaneously. Both faculty and staff use Banner, but also administration uses Banner, and guess what? Even students use Banner. It's an enterprise-wide system, and it supports multiple processes within the organization, and there are hundreds or thousands of users. Procedures are formalized and extensively documented, and users always undergo some formal training on how to use the procedures, how to use the system. Sometimes enterprise systems include categories of procedures, and users are defined according to levels of expertise with the system as well as by level of authority. In other words, different users, depending on the nature of their job, will have different kinds of access and different kinds of interaction with the system. So someone who works in finance would not be able to manage students' grades. And likewise, someone who works in registry office will not have access to payroll-based activities or payroll-based processes, because that's a function of another department. So, after all this talk about business processes, how do we document business processes? Well, there are different ways of doing that. But each way tends to serve a different purpose. Here we have three different methods: listing the steps in a process, creating an illustration that tries to show what the process looks like, but this kind of illustration is really more or less for broad showcasing. It's not really a technical document. And lastly, we have something called a process flow diagram, which is a technical document. So let's go through each of these and we'll see, if in this little write-up there's a little pro and con to each. So, lists. This is a simple written list of the major steps in a process. So, step 1, write it down. Step 2, write it down. Step 3, write it down. While a list will show a basic sequence of the order in which steps occur, it often, and in fact in reality, does not reflect what actually happens when the process is executed. When you write down a list of steps, it is usually written in a particular order. Step 1, 2, 3, 4, 5, 6, 7, 8, going on. And that implies that the process follows those steps in that order. But when you write a process down using a list, that's kind of deceptive, because in reality, what if a step has to be redone? What if something is incomplete? What if a qualified person gets to skip a step? For example, when you applied to come to Custard, if you had A levels, you got to skip the placement exam. You didn't have to do a placement exam when you were matriculating into Custard. So a list is okay, but it really doesn't reflect what really happens. And therefore, it cannot be used, for example, to train people as to how to adequately be prepared for a process. Illustrations. Now, illustrations which are used for publications such as your textbook, such as a brochure, or maybe even a corporate report. These are mostly used as an enhanced version of the list of steps that we talked about before. And illustrations tend to show or use representative graphics such as maybe people, objects, computers, cars, bikes, whatever it is, as well as maybe lines or arrows that show the basic flow of the process. So it's much better than a list because it's visual. And they say, a picture gives 1,000 words. So in a very quick and easy way, you can show what a process looks like. And they're good. Illustrations are good. They're not limited in the ways that a written list is. So illustrations are very, very useful and significantly better than a written list of steps. But as the intended purpose of an illustration is not technical in nature, it will often not fully reflect the reality of the process. In other words, what happens on the ground, what happens when people are actually doing the job and doing the activities, is often a lot more involved and a lot more intricate. And illustrations are not designed to give you all of that detail. It is essentially an enhancement to a written list of steps. And I actually have an example of what an illustration looks like. It's on our very, very last slide in this lecture. That's slide number 29. So if you want, in going through your documentation and the downloaded slides, you can skip across at number 29 to see what it looks like. The third and the most important version that we are going to be dealing with is called a process flow diagram. This technical drawing of a process is designed to represent every aspect of how a process works. And that's the difference with a process flow diagram. And in fact, you can probably guess that this is the real deal in its very name. Its name says process flow diagram. While process flow diagrams can include similar graphics or graphical objects used in illustrations, including people shaking hands or people using computers or whatever it might be, they also use a very specific set of symbols which indicate the type of activity that is taking place in a step in the process. And what we mean by that is it's not just that you have a step. What is the nature of that step? Is it that a document is being filled out? Is it that we are accepting data? Are we disseminating data? Are we converting that data into information? Are we storing it? Are we making a decision based on what we know? That's what we mean by type of activity, not just what the name of the activity is, but what type of activity it is. We also have arrows, similar to illustrations, that show the logical flow patterns of the various steps in the process. But unlike illustrations, these arrows demonstrate what we call logical flow. And logical flow is not always sequential, meaning steps do not follow one after the next necessarily. Sometimes we have skips. Sometimes we branch out into two different directions with two different groups of customers, as the case might be. And sometimes we have to repeat a process. So arrows represent all of these different logical flow patterns. These drawings, believe it or not, are very easy to learn and are generally simple to use, to read and to create. Process flow diagrams can also be used to illustrate business processes, software, and information systems. So now you see why I'm spending a lot of time trying to teach you not just business processes, but how to document business processes. Because documenting a business process is basically the same as documenting an information system. Now, I'm not just going to read to you about what they look like. I want to show you what a process flow diagram looks like. Now, to the untrained eye, this may seem like a very technical document. And I'm not going to get into any details of how to read this. Why? Because in this week's class material, in addition to the full-fledged lecture, which this is, you also have a supplemental lecture, which I'm calling a tutorial. And in that tutorial, I'm going to teach you how to create your own process flow diagrams. I'm going to teach you how to read them. I'm going to teach you how to create them. I'm going to teach you what each of these shapes represent. So here we have one particular shape. It has a particular name. I'm not going to get into any of those details now. Here's a different shape. Here's a different shape. These shapes represent a type of activity, as was mentioned before in our previous slide. And of course, we can see the pattern of the arrows. Yes, we have a sequential process represented by our black arrows, but we also have a loop back. We also have a branching. So we can see how a process varies from simply a static list of steps. So you will get to see this particular process flow diagram again in our supplemental tutorial on how to create process flow diagrams. Right, so let's move on. So how can information systems improve process quality? Processes are the means by which people organize their activities to achieve the organization's goals. As such, process quality is critical and possibly the most important determinant of organizational success. Now, again, everything that an organization does is literally broken down into a series of processes. You're not running your business by the seat of your pants. You're not doing things by VAPs, as we say in Trinidad. There are defined processes, there are defined methods, and there are reasons why these methods have been defined in this particular way. And as such, you can define and build quality into your processes, because the success of your processes determine the success of your organization. Because if your customers are unhappy, your process failed them, your process frustrates them, your process cheats them, or whatever it is, then ultimately they will not come back and your organization will fail. Now, the two dimensions of process quality, as is with everything else in business and in management, are efficiency and effectiveness. Process efficiency is a measure of the ratio of process outputs to inputs, meaning that you're able to produce a certain amount of outputs with a certain amount of inputs. The less inputs that you use to create the same amount of output means that you're becoming more efficient. So if it takes you less time to produce 10 units, then you are more efficient. Typically, you took 30 minutes to produce 10 units, but now you are taking 25 minutes to produce 10 units. And in a month's time, you are taking 20 minutes to produce 10 units. You are becoming more efficient. If process B can produce the same level of output for less cost than process A, or produce more output for the same cost, then process B is more efficient. The other issue, of course, is process effectiveness. And this is a measure of how well a process achieves organizational strategy. In other words, think of effectiveness as a bullseye, a dartboard. When you throw that dart, if you hit the bullseye, you are being extremely effective. If you miss the bullseye, you are somewhat effective, but you're not quite there. If you miss the bullseye altogether and your dart lands on the wall or lands on the floor, then you are not being effective at all by any measure. And that's what we mean by effectiveness. How on target are your processes when it comes to achieving organizational strategy? If an organization differentiates itself on quality customer service, that is how your company defines itself. That is your mantra. That is how you put yourself out into the public. Hey, we take care of you, the customer. We have quality customer service. You can always depend on us. And if that's how you differentiate yourself from your rivals, and then when a customer comes in to deal with a problem, and that process requires 5 days for you to respond to that customer's issue, then that process is ineffective. You are not achieving what you set out to achieve with your process. So, how can processes be improved? Organizations can improve the quality, that is, the efficiency and or the effectiveness of a process in one of 3 ways. 1, you can change the process structure. 2, you can change the process resources. Or 3, we can change both the structure and the resources. Let's get into each of those. So, let's change the process structure. Improving a process by changing the process structure can be done in several ways. 1, changing the sequence of the activity steps in a process. So that's structural. And instead of doing things 1, 2, 3, 4, 5, we might decide it might be more useful to do 3 before we do 2. Now, I'm not talking about counting. I'm talking about what those numbers represent in terms of what the activity is. All right. Another way is adding additional steps to a process, such as adding a quality control verification step to ensure that the customer receives exactly what was ordered, reducing or eliminating returns or complaints. Remember, we talked about earlier that we're finding a lot of people returning our products, and our company wants to find out why. Well, we can now introduce an additional step to the whole process, and that step is a quality control verification step. And this verification step is to verify or to ensure that a customer gets exactly what they ordered, and that what they ordered is functional, it's working properly. Step three, sorry, not step, way three of how to change the structure. We can remove unnecessary or obsolete activity steps in a process to make the execution of a process faster or less frustrating for a customer. How many of you have ever had to do something at a business or in Custat or at a bank, and you thought, or maybe even licensing office, and you thought that, oh, this, what you have to do here is an unnecessary step. Let's say you want to renew your driver's permit. They already have all of your information. They know your height. They know, what you look like. They know your address. They know your name. Why do you have to fill out a form all over again, handwriting? Why can't you just tell them, listen, my driver's permit number is XYZ123? They pull it up in the computer system. Okay, good. Here's your information. Is your address the same? Yes, my address is the same. Good. That's it. No. So you remove an obsolete or an unnecessary step of forcing people, in this case, to fill out a form again and again and again with information that they already have. They already have that information about you. And when those unnecessary or obsolete activities are removed, it makes the process faster and therefore less frustrating for a customer. And four, replacing an activity that is manually done with an activity that is computerized or that uses an information system, making it faster and more accurate. And again, I go back to licensing office. It's not just a matter of removing your need to fill out a form, but it's also replacing your need to fill out a form with an automated way or computerized way. You bring your old driver's permit, and let's say that driver's permit has a magnetic strip at the back, which in Trinidad we don't have, but in many other countries there is a magnetic strip like your bank card or your credit card. There's a strip at the back of your driver's permit. You swipe your driver's permit and it pulls up all of your information right there, so you don't have to fill out anything. So it pulls all of your data from the server. Isn't that much more efficient? When a police officer stops you by the side of the road and is giving you a ticket, which none of us want, but if that police officer now has to take 20 minutes to manually write down the person's name, the person's vehicle number, the driver's permit number, the address, that means that you are parked up at the side of the road for 20 or 30 minutes while this officer takes his merry, slow time to fill out all these details. In other countries, what you have happening is that the police officer swipes your driver's permit and it connects wirelessly to a central system that fills in all of your data into an electronic form. And then, of course, the officer prints your ticket with a portable printer, handheld printer, that's part of this whole system. And you get your ticket in your hand. And if you want, in some places, you can give the officer your credit card and you can pay the fine right there, right then and right there. So the whole process of getting ticketed, paying your fine, and moving on is much faster, much more efficient, because you have looked at your process, you have looked at which parts of your process structurally need to change, and you have changed it. So changing the structure of a process can result in improved efficiency, improved effectiveness, or both. So now let's change the resources. Another way to improve process quality is to change the allocation of resources for those processes. This can be achieved in many ways, which can include, and these three here are just examples. You can assign more persons to work on an activity or on an overall process. For example, 4 painters can paint a room faster than 1 painter. That's obvious. So by assigning more resources, in this case, the resources are people, but the resources could be money, The resources could be computers, the resources could be vehicles, the resource could be anything. But in this example, by assigning 4 painters to a particular room, that room gets painted faster. Each painter can handle 1 wall, each, simultaneously. Here's another way. Assign better tools and better equipment to an activity or to a process. For example, replacing a paintbrush with a paint roller. Paint rollers are faster than paintbrushes. Everybody knows that. Or you can replace a paint roller with an electric paint sprayer. And there's literally nothing at present that is faster than an electric paint sprayer. Right? Here's a third way. Using upgraded technology and information systems. And I bet you knew this was coming, right? Because this is MIS. For example, replacing a standard cash register machine in a supermarket with a barcode scanning point of sale terminal that is part of a supermarket information system that automates price verification when you scan the barcode, inventory monitoring and management, so that every time an item is scanned, you know you have 1 less item, and then when it gets to a particular level of inventory on your shelves, it automates stock reordering. All right, so yes, this is an example of better tools, but we're being very specific. We are upgrading technology because a cash register is technology, but we are upgrading that technology into something that is much better, something that is information systems connected. Management must balance the cost of the changed or increased resources because 4 painters are simply more expensive than 1 painter, right? So management must balance the cost of the changed or increased resources with the volume of work to be processed, thereby justifying the cost of the different resources used. Obviously, a contractor is not going to assign 4 painters to paint 1 room if at the end of the day the cost of those 4 painters will make the contractor lose money. In other words, the job isn't paying enough to afford 4 painters. Maybe the job is paying enough to afford 2 painters per room. In a case like that, you might decide to allocate, well, 4 is the ideal, but right now I can afford 2 painters, I can still make a profit. If I assign a 3rd painter, I will lose money. You get the idea. And of course, you can change both the structure and the resources. And there's really nothing here to cover because we just covered changing the structure and changing the resources. And here we're talking about doing both at the same time. Okay? So how can information systems improve process quality? And we've already hinted to you and even showcased a few times how information systems can improve quality, such as having a barcode strip at your back of your ID or your driver's permit, and a police officer can swipe your driver's permit, and it makes the whole ticketing process a lot more efficient. Equip the police officer with information systems, connected tools, handheld or vehicle-based, that can pull up your information and can print out your ticket. We talked about a cash register versus a point-of-sale terminal in a supermarket. All of these are information systems based ways of improving processes. Nonetheless, we're going to get into the details. So, information systems can be used to improve process quality by 1. Performing an activity. In other words, the IS is performing the activity. 2. Augmenting a human who is performing the activity. As in, the human is now equipped with a better tool, and with the technology, the human is able to perform the activity much more efficiently or effectively. And 3, controlling data quality and process flow. Let's get into each of those. So, performing an activity. Information systems can perform the entirety of a process activity, such as if you were to go shopping on Amazon.com. When you look for an item, let's say you want to buy, a t-shirt on Amazon.com. secretly there isn't a human being on another computer monitoring what you are doing and responding to everything that you type or everything that you click on. That's not the case. In the case of Amazon.com, it is an information system that you are interacting with in its entirety. There is no other human being involved at that level. The first human that's going to be involved with your order is when somebody has to go and find your item on a shelf, pick it out of the shelf, and put it in a box, close that box, and whatnot. And in some cases, even that is automated. So again, for example, when you purchase from Amazon or any other online retailer, information systems check your credit while your transactions are being processed and so on and so forth. In fact, the entire purchasing activity from Amazon's side is completely managed by Amazon's e-commerce information system. Or how about reserving a seat on an airline, which is done automatically? All of the reservation activity is done by an information system. Okay? Augmenting a human performing an activity. A second way that information systems can improve process quality is by augmenting the actions of a human who is performing that activity. For example, consider the process of managing patient appointments. To schedule an appointment, patients call the doctor's office and speak with a receptionist who uses an appointment information system. That information system augments the appointment creation activity. It makes the work of the receptionist who is making your booking a lot more efficient. For example, it's not just writing your name down on a time slot, because anybody can write that down in a diary. Okay, this patient is going to show up on this day at this time. Sure. But what about pulling up information about that patient? What if the doctor has 3 patients or even 2 patients with the same name? And in Trinidad or in any other country, that easily happens. And by simply giving a name, the wrong patient information might be assumed. So an appointment information system will not just book that appointment, but it'll also make sure that this is the right patient so that we can pull up the right patient file so that we have a head start when that patient shows up and we're not looking at wrong information about this patient and potentially prescribing wrong or harmful medication. Right? That's an example. And then, of course, we have controlling data quality, process flow. A third way that information systems can improve process quality is by controlling data quality and process flow. One of the major benefits of information systems is to control data quality. The IS can not only ensure that correct data values are being input, it can also ensure that data are complete before continuing process activities. In other words, if you are putting in customer information and you're putting in the customer's phone number and you accidentally leave a digit out, the system will not allow you to move forward until you correct the mistake. In other words, it knows that a phone number should have 7 digits. If you try to put in 6 digits or if you try to put in 8 digits, it will let you know there is a mistake. Right? So that's a way of ensuring data quality. Information systems also have a role in controlling process flow. If a process is controlled manually, then someone, say a salesperson, will obtain the order data from the customer and take whatever actions are needed to push that order through the 3 steps in the order process. And we're just assuming that there are 3 steps in an order process. If the salesperson gets busy or is distracted or is away from work for a few days because maybe he's sick, maybe there's an emergency he has to take care of, or if there are unexpected delays in one of the activities, it is possible for an order to be lost or the approval process be unnecessarily delayed. And we all know that happens. Why is this thing taking so long? My grade should have been changed. The documentation was already sent down to registry and my grade should have been changed. Why is it taking so long? Has it been lost? Is it sitting on somebody's desk covered up by other documents? I requested to drop a course. Why is my drop not being processed? I requested to add a course. Why is my process taking so long? When humans are involved, things happen. As we say, life happens. And sometimes, well, something else happens. I won't say what it is, it's obscene, but you know what it is. Let's move on. If, however, an information system is controlling the order approval process, then it can ensure that steps are performed in accordance with an established schedule, ensuring that the process is not delayed and ensuring that customers are satisfied with the company's efficiency. When you order on Amazon.com, and if they say your order is going to be delivered tomorrow, if a human is involved in receiving that order, and then when processing your order has to get it from his desk, leave to do something else, and then somehow gets detained, or in some other way, maybe a window opens and the document is blown away, things happen. It is delayed. With an information system managing your order, it is going to be done on time because computers don't get distracted. Computers don't get called away to focus on something else. New topic. What are information silos? And I bet you're wondering, why do I have a picture of a farm at the bottom of this page? Well, we'll get into that. The term silo is derived from the large storage units on farms that allow farmers to store different types of grain separately, such as wheat and corn and barley and whatnot and whatnot and whatnot. So these are silos that you're seeing here. On this particular farm, we are seeing 3 silos. Farm silos provide the following benefits. They prevent different types of grain from mixing. They prevent rodents and pests from getting to the grain. They prevent exposure of the grain to the elements like rain and wind and so on. And it prevents contamination of the grain. So a silo is a good thing, right? And definitely on a farm, silos are a good thing. But we're not taking a farming course, are we? No. We're taking an MIS course, and we're going to be dealing not with silos, but information silos. In a business, however, an information silo is a bad thing. An information silo is a condition that exists when data becomes isolated or contained in separate departments or in standalone departmental information systems. So just as how we had on a farm where silos were intended to keep one type of grain separate from another type of grain and to prevent any kind of contamination or exposure or whatever it might be, that happens with an information silo as well. Information gets siloed, it gets contained, and when it gets contained, it cannot be shared. It is not exposed to the rest of the organization. And that's not what we want in a business. We want access to our information. We want access to our data. An information silo is never really intentionally set up. It just happens. It exists because of some condition. For example, for a smaller business, we often find that these small businesses can't afford a big enterprise-wide information system. So you tend to find that they buy an accounting system for the accounting office, and a few years later they may have bought an HR system for HR, and then a few years later they may have bought a payroll system for the payroll department. So everybody gets their own system, and they're using commercial software, they're using software they can buy. And that's not a bad thing necessarily. The problem is that these different programs from different companies that manufacture these programs or that develop these programs did not design their programs to share data in an integrated way across the whole organization. In fact, one of the selling points of their programs was that they will keep your data safe. And you bought the program for your payroll department, or you bought this program for your accounting department because it was able to keep your data safe. But in keeping your data safe meant that it could not be shared, or it cannot be easily shared with any other department. And that's a bad thing. So for example, Department A generates or accumulates certain types of data, but that data may have minimal usefulness to Department A. As such, the data exists, but it is not used. Department B may have need for that data, but because B is unaware of that data's existence somewhere else in the company, or perhaps because the data is stored in a format or in an information system or software that is unusable or inaccessible to Department B, then that data becomes trapped in Department A. And Department B just simply cannot use it. The organization as a whole is unable to benefit from this trapped data, which is currently stored in this virtual silo, this information silo. So you see why information silos are bad. It's not that they set it up intentionally, it just happens. As your company grows and you realize just how interdependent departments are. The software that you're using in one department is incompatible with any other department, and therefore data cannot be shared. And sometimes you don't even know that that data is being accumulated. So what are some of the problems caused by information silos? Information silos do cause a number of problems for businesses, and these include, trapped or inaccessible data, which we talked about just now. Multiple departments are forced to generate the same data independently of each other. So that is going to cause you to duplicate effort. And duplication of effort very often means duplication of resources, because you need to produce that data twice. So two separate departments are producing the same data separately and using equipment and other resources separately to produce that same data, simply because one department that produces it cannot share it with another department that needs it. So they both end up producing it, and they may produce it with completely different resources. The duplication of resources may not be the same identical resources. They may have different resources based upon the nature of their departments. But either way, it's costing the company more money to produce this data a second time. Here's another problem: inconsistent data. As the data about a particular entity, and we talk about entities in databases, remember chapter 5, the data about a particular entity, for example, a client, or maybe a supplier, but let's stick with client for now, that is stored by one department may be outdated and not reflect the updates about the same entity stored by another department. Now remember, we said in the previous point that with multiple departments generating the data, that's duplication of effort and duplication of resources. But what if one department gets the update that the customer's address has changed, or the customer's phone number has changed, but the other department does not get that data? The one department gets it because they interact with the customer more often. The other department that does not get that update is because they need the information, but they don't interact with the customers directly. So they are unaware that the customer's phone number, or the customer's address, or maybe even the customer's last name in the case of a woman who gets married. Here's another problem: extra expense for the company to acquire additional storage, because you are storing more data, duplicated data. So it's not just the duplication of resources needed to produce that data, but you now have to get additional storage, well, to store that data. And lastly, we have reduced competitiveness, as the company may not be able to make timely or accurate competitive decisions since the needed data may not, and there should be the word be there, may not be available to the departments or decision makers who need the data. Because one department has the data, it's in a silo. The other department or departments need that information or that data, and they can't access it. So because they can't access it, they don't make timely decisions, or they don't make good decisions, because they're simply guessing, because they don't have the data available to them, because the data is trapped in a silo. So how do information systems solve the problems of information silos? Well, as defined, an information silo occurs when data is stored in isolated systems. The obvious way to fix such a silo is to integrate the data into a single database and to revise applications and business processes to use that database. Now, that may sound like a complicated thing, but let me break it down. Right now, the silo exists because accounting has their own database that is owned by the accounting software. Payroll has a separate payroll database. HR has an HR database. Marketing has a marketing database. And all of these databases are used by the software that each of those departments use. The obvious way to fix a silo situation is to not have every program using different databases, but to have them using one database. And then, of course, obviously, a commercial program that you bought that handles accounting cannot use just any database. It has to use its own database. So that means you're going to also revise your application. You're going to replace your applications. And you're going to use applications that can now all share the same database. When everything shares one database, because you have new software, each software being used by the respective or the relevant departments, but all using one database or a group of related databases, the data is no longer trapped because the data is now in a collective. Many small organizations do, as I said before, use dedicated application software and database systems within their departments. And while these solutions may be industry standard and best in class for what they do, these applications remain standalone systems. They're designed to work by itself. They're not designed to integrate with other programs from other companies in other departments. As organizations grow, the issues caused by information silos become more acute, they become stronger, they become more significant to the company, and their efficiency and competitive effectiveness suffers. One of the best choices available to businesses to eliminate information silos is to replace their individual standalone departmental applications with an enterprise-wide information system. And that is the obvious way. The obvious way to fix a silo is to use an enterprise-wide system, a single database, and you replace all of the various applications into the applications that are part of the enterprise information system. So, enterprise systems. An enterprise system, or more specifically, a type of enterprise system that we call an ERP, or an enterprise resource planning system, is a cross-functional information system that provides organization-wide coordination and integration of key business processes while facilitating planning and resource utilization across all levels of your enterprise. In other words, it is cross-function, meaning it is marketing, it is manufacturing, it is HR, it is accounting, it is finance, it is customer service. It is cross-functional, and it provides organization-wide coordination. That means that you can now, at the highest level, coordinate what is going on across your company, because higher level managers can now see virtually what is taking place across the organization using the system, because the data generated by each part of the ERP is accessible to high level managers. Enterprise systems are actually a collection of related individual software programs that use a shared database or a shared set of databases. Each individual program, which you just referred to, or more correctly, it's called a module, is designed around the needs of different organizational functions or departments, such as marketing, accounting, sales, asset tracking, inventory management, etc., 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 and the list goes on and on and on and on. Because all modules use the same databases, all organizational data is harmonized, and all data is fully accessible to all authorized users, depending on their roles and managerial level within the enterprise. In other words, as I said before, you don't want somebody in customer service accessing payroll data or accessing accounting data. Each department can access its own data. But if you are a high-level manager, then you can access all data, because you need to access all data so that you can get an overview of what is taking place with the company so you can make better decisions. Access to full ERP data allows management at the highest levels to perform richer data analytics and develop better business intelligence, thereby improving competitiveness and responsiveness. When you understand what is going on competitively, when you understand what you are capable of doing based on your analysis of what is going on in your company, you can make better decisions, you can be more competitive, and you can respond faster to your customers' needs or to a rival's activities, whatever they're doing. Enterprise systems are typically developed around specific industries. This means that ERP systems are vertical software systems, and you can check on vertical software, just check chapter 4 for a little reminder. The primary purpose of an ERP system is integration. An ERP system allows the left hand of the organization to know what the right hand is doing. In other words, that's just a phrase. This integration allows real-time updates globally, assuming that your company is a global company, whenever and wherever a transaction takes place. Critical business decisions can then be made on a timely basis using the latest data. As mentioned earlier, Costat uses an ERP called Banner, which is specifically designed to serve the needs of tertiary academic institutions. In other words, the Prime Minister's office has no need for Banner. They have no use for Banner. Penta Paints has no use for Banner. Okay, the Port of Spain General Hospital has no use for Banner, even if they have in-house training. Banner is designed specifically for tertiary level academia. Another ERP example is one called Epicor ERP, which is specifically designed to serve the needs of manufacturing companies. You get the idea. So what is the structure of an ERP? At the core of an ERP is a main database. Now, as I said before, some ERPs are designed with multiple databases at its core, but all of these databases are linked so that data can be accessed and can be related across all of the databases. Now, the term related across should be familiar to you after covering chapter 5, okay? Because that's what databases do. They allow you to create relations or relationships between one set of data with another set of data, with the data in one database with the data in another database. Modules specific to each department, function, process, or specialty within the company are installed onto the computers of the relevant employees and managers. So the employees in the finance office will be provided with the finance or the accounting modules. The employees in the HR office will have the HR modules installed in their office. The employees in the manufacturing department, they will have the manufacturing modules installed on their computers. Each module is allowed to access only the database tables and fields that are relevant to the module's functions. So if the ERP uses one database, let's keep it simple, one database, the software on your computer, let's say you are in accounting, will only access the accounting tables and the accounting fields. It will not access the HR tables and the HR fields. It will not access the sales tables and the sales fields. It will only access those relevant to accounting. This ensures security and privacy of data, even though it is all in one database. Unauthorized employees, therefore, will not get access to data they should not have access to. They will not be able to view it. They will not be able to interact with that data. They will only be able to interact with data that they process and that they use. Okay? That's their job, so focus on their own job. Some high-level managerial and analysis modules can access the entire database, giving management a complete view of the entire company's operations and outlook. So, even though an HR module will only access HR functions and HR databases database tables and fields, the high-level managerial analysis modules, the analytics modules, the business intelligence modules, the assessment modules, those that are used by the VPs and the president and those high-ranking people, they can access everything so that they now have a view of the entire company, what's going on in the company, and can now see and determine what the outlook is for the company. Most ERPs feature a powerful development interface that allows qualified IT professionals to customize the ERP to meet the exact needs of the company, as well as to evolve or upgrade the ERP as the organization grows, gains new capabilities, or establishes new processes, procedures, rules, or policies. Costat, for example, Costat has a fairly big IT staff. I don't know how many people work for IT in Costat. It could be 30 odd employees work for IT. And that's a fairly good number. It might be less, but let's just simply say it's 30. Costat separately also has about 20-something people who are focused on nothing else but Banner. And they are the ones who create the various modules for Banner. They're the ones who customize the modules. They're the ones who make sure that Banner works properly, and that as Costat's needs changes, as new rules, as new programs, as new policies are implemented, they modify the system to facilitate how the departments need the modules to work. So to do that, separate from the modules, there is a development interface, a master program that allows these qualified people to create, to modify, to customize how Banner works. And that is the same for all ERPs. Because ERPs are purchased, but since no two companies are identical, ERPs are then customized. And that's just at least something good for you to know and understand. And we're going to wrap up our lecture here by just looking at an illustration, taking you back to our earlier discussion how to document processes. And this illustration shows you basically what an ERP looks like. At the very center of the ERP is, of course, a database. Obviously, some ERPs use multiple databases, but it depends upon the size of the ERP and the complexity of the ERP whether you have one or multiple databases. But nonetheless, at the very core of this system is an ERP. And then at each department, you have a separate module, all of which interact with the central core databases. So in project management, you have the module for project management. In asset management, you have a module for asset management, HR management, sales and marketing, customer service, customer relationship management, supply chain, financial management, and then of course we have data analytics and business intelligence, which of course will access everything. Now this is not a process flow drawing at all. This is just an illustration, and it just shows you a concept of what it looks like and how it can be used. But this is not a process flow. This is just a simple illustration, and I just included this so you can get a sense. At the very core is the ERP, and at every level in the organization, from the operatives to supervisors to middle managers to senior executive managers, they all have modules in their related specialties that allow them to be able to interact with this ERP. And in so doing, can streamline how the company achieves what it achieves, and you eliminate those information silos. And there we have it. That's it. That's the end of our lecture, but it's not the end of what you're going to have to do this week, because as I said before, there's a separate tutorial teaching you how to create your own process flow diagrams that you're going to have to view and be versed in. Why? Because your end of semester project is a process flow project. That's right. In your groups, you are going to have to create process flow drawings, not one, but two. So you're going to have to learn how to create a process flow diagram. Now, in addition to the lecture, the tutorial that I'm putting there for you on our e-classroom, I will send you when the time comes, which is when I give you the assignment. When I give you that final assignment, I am going to provide you with a series of links to YouTube videos that will show you different methods of how you can go about creating your own process flow diagrams. But again, when we come to that time, we'll cover it then. But for now, that's it. So see you in our tutorial video, and then see you again in our video for Chapter 8. Everybody take care, be safe. Bye for now.